let us continue with Lampel coding. In last lecture, last video lecture, we have seen how to code data sequence which comes in alphabets. Now in this lecture, we'll see how to encode the data sequence by Lampel coding. The data sequence 0 0 0 1 0 1 1 1 0 0 1 0 1 0 0 1 0 1. Now it is accomplished by dividing data into segments. Here again the same steps we are going to follow. Here we have already seen in first lecture, but even though I am repeating here, first step is to divide data into segments. Here this data we have to divide into segments. Okay, and these segments are the shortest segments or sequence and should not encounter previously. Each and every sequence is unique sequence. It should not get repeated again. That care we have to take in here. Next is all segments are referred as phrase. We referred these segments as a phrase. Next is we encode phrase by prefix and the last bit. Here we encode this phrase by prefix and last bit. Okay, these are the bits 0 0 0 1 1 0. Okay, up to 101. These are the bits. Here, first of all, write down the position of bits. Position here 1 2 3 4 5 6 7 8 and 9. See, 0 and 1. First and second position is always uh, common. That is at first position 0 will be there, and at second position 1 will be there. Okay, and from third position we have to taken the bits from the given data. Okay, now see, here we can't take the first 0 as the 0 is already encountered here. So here I have taken the 0 0 sequence. So here 0 0 has been written here. Okay, now and next segment is 0 1. So here 0 1 is written. Next is 0 1. 0 1 is already appeared here. So here we can't take 0 1. So here I have taken 0 1 1 phrase or segment. So 0 1 1 segment is taken here. And the next sequence is 1 0. As 1 already encountered here. So here I have taken 1 0. 1 0 is there. Next is 0 1. Again 0 1 is appeared here. So 0 1 0 sequence we have taken. Next is 1 0 0 and the last is 1 0 1. This is the position of these sequences. Now let us write down the numerical representation of these data bits. Here we can represent this 0 by 1. 1 is represented by 2. 0 is represented by 1 and 1 is represented by 2. So here whenever 1 comes, here I will write down 2, or whenever 0 comes, I will write down 1. So again last bit and prefix, we follow the same steps. Last bit is 0. 0 represented by 1. Is not represented the position of 0 is 1. Therefore, position of 0 is 1 and this 0, again 0 is 1, no? So here I have written 1. Again for 1, 2 has been written, and for 0, position of 0 is 1. Okay, last bit is 1, so 1 is represented by 2. So 2 is written here, and 0 1. 0 1 is represented by 4. So 4 has been written here. Again for 1 0. Last bit 0. So written 1. And prefix is 1. So for 1 here we have written 2. Again for 0 1 0. Last bit is 0. So here I have written 1. And for 0 1 I have written this 4. 100, last bit 1, sorry, last bit 0. For 0, write down 1, and for 10 is represented by 6, so I have written 6 here. For 101, last bit is 2, the position of 1 is 2, and 10 is represented by 6, so here I have written 6. Now these are the numeric values of these data segments. Now last step is to do the encoding. How to encode this? We have to encode this. So here you can see this 1, 2, 1, 1, 1, 2. For all these values here we have to encode it. For 1, 1, the sequence is 0, no? So here I have written this 0. For 2, 1 is there, so I have written 1. Okay, now previously there was only 1 digits. Here two digits are there. So for 1, the representation of 1 is 0 here. So here I have written 0. And for this prefix bit, 1 is written as 001. Okay, and here there is no prefix, so I have written 000. Here again I have written 000. Here the numeric value is 1, 2, and 2 is represented by 1. So 1 is written here, and for this prefix 1, it can be represented by 001. Okay, for 2, next is 42. 2 is represented by 1, and 4 represented by 100. Again 21, 1. For 1, representation of 1 is 0, and for 2 it is 010. For 41, 1 is represented by 0, and 4 is represented by 100. 61, 1 represented by 0, and 6 is represented by 110. Here 62, 2 represented by 1, and 6 represented by 110. Now this is digital encoded data. This is called as Lampel coding. Thank you.